This is a video covering section function F of the functions module. In this video, as promised, we're going to look at common functions and their graphs. It's important that you try and learn the basic shape of different graphs and what their function looks like. So the first one's just a constant graph in the form of f of x equals c. Okay, so for example, f of x equals 2, f of x equals -4. Okay, what you're getting in this case is a horizontal line and passing through 0, c. So this function here would pass through 0, 2. This one would pass through 0, -4. Okay, so here's an example of the graph here. It's a nice straightforward horizontal line graph that was covered in TM1. The next one's a linear graph. Y equals, or f of x equals mx plus c. You might also see that as f of x equals mx plus b. That's the form covered in TM1. Okay, in this case, the slope is the m, so the gradient or the slope, and the y-intercept is 0, c. So for example, if you had y equals 2x plus 3, the slope is 2 and the y-intercept is 0, 3. And you can see an example here with this line that would have a positive slope, remembering that lines going in the opposite direction have a negative slope. Okay, so in this case m is less than or equal to 0. Here m is greater than or equal to 0. Now let's look at a quadratic. We looked at quadratics in our quad module. The basic form of a quadratic is f of x equals ax squared plus bx plus c. So you can see that there's x, the highest power of the x squared is the x term is squared, so that means it's a quadratic. The graph forms what we call a parabola. Okay, your y-intercept is at 0, c, and that's because if you plug in x is 0 in here, you end up with c, and your x-intercepts are given by the quadratic formula. Also remembering your vertex, x is at -b over 2a, so plugging that into your original function and you'll get the y value. And you can see here that we have an example of a parabola, what I call a happy parabola. So let's look at some other examples of parabolas. Okay, I'm just going to put in a couple to start with. If we have y equals x squared, that's our basic parabola. So it looks just like that. So that's a very basic one sitting at 0, 0. Now, if I put in y equals -x squared, you can see that's exactly the same shape, but it's reflected on the x-axis. So that's your sad parabola. Okay, we looked at this in quadratics. And then you can have your parabolas moving around, so they don't have to be sitting on the axis like that. So for example, y equals x take 2 squared, oops, mistake there, y equals x take 2 squared, and you can see that's moved. Okay. The next one is a cubic, something different they haven't seen before. A cubic has, whereas a quadratic the highest power was 2, in a cubic it's 3. Kind of makes sense, doesn't it? And again, the y-intercept is given by 0d, because if you plugged x to 0 in here, you get d. Now we have two types of cubics. This one here is what we call a basic cubic, and that's just of the form f of x equals x cubed. Okay, now the reason why we get that is there's only one x-intercept. Okay, because x is 0, f of x is 0. Okay, our other type of cubic has two turning points, a minimum and a maximum. That graph could also be in the opposite direction and look like that. Okay, so that's what a cubic looks like. So let's look at some examples. We'll get rid of our previous ones. Okay, so let's look at the basic one, x cubed, and we'll also, so there's our basic. If I put in a minus, you might try and predict what's going to happen here. Okay, it's the reflection on the y-axis. Okay, so that's a very basic cubic. Other type would be something like y equals x plus 3, and I keep getting the bracket wrong. If I square that, we have our quadratic, which we just looked at. If I change that squared to a cube, you can see there you've got your basic cubic moved. Okay, we'll look at one more type. If I had y equals negative x plus 2 x minus 1, that would make a quadratic if I expanded that. So we'll go again, we'll put another bracket, x plus 4. Let's see what we end up with. You can hardly see it, can you? Okay, we'll see if we can make that look a bit darker for you. Okay, so you can see that cubic coming through here. Okay, make it a bit clearer. What I might do is get rid of those ones so you can see that cubic. Okay, if I took away the negative that was out the front, you can see it's changed. So whereas before it started up here, down and there, now it's down and then up. So that's your basic cubic. Next one, a square root function. We've looked at a few of these, haven't we? We know that we've got a domain restriction because of this square root sign here. Everything that's inside this square root has to be greater than or equal to 0. So that's our domain restriction. And you can see the graph, the basic graph sitting right there. Okay, if I wanted to look at some other examples, so y equals, now square root, I'm going to put to the power of 0.5 so we can see that. So x plus 2, and we'll put that to the power of 0.5. And you can see that square root graph there. You can see how it's very flat. The reason being, if you plug in one of these values, you then have to square root it, so the y value is quite small. It's a very flat graph. If I had a negative out the front, you can see it just does the horizontal reflection on the x-axis. Okay, absolute value graph, another different one. We have an absolute value sign here. Now you know from inequalities and absolute values that an absolute value sign makes everything positive. What happens there is we end up with a corner, okay? Because our y value can't be, or our f of x can't be negative, so it creates a corner here. That's our basic f of x equals the absolute value of x. Okay, so if I look at one here, so we've got absolute value of x, well, we might go take 5, put in our absolute value sign, so we're going to have a corner happening. So you can see this corner happening at x is 5 because that's the x-intercept. If I then took 3 away from the bottom, you'll see that this whole graph moves. So it's just moved down. Okay, and we'll talk about that in more detail later. Okay, hyperbolic graph, which we talked about when we did asymptotes. Anything with a fraction in it, basically. Okay, because we end up with a vertical asymptote and a horizontal asymptote in this case. In terms of graphs, I won't do too many because we've kind of looked at those. So our basic one was y divided by x. So you can see that there. And then if I put a negative in front, you can see that whereas before it was over here, now it's over in this section. I can then move it. Again, we'll talk about these in more detail, the translations later. But if I put that x in brackets, you can see what I'm doing here. Okay, you can see that that's now just moved across. Okay, exponential. An exponential function, do you believe, has an exponent in it. So anything to the power of x. And your exponential function looks like that. You might have heard someone saying something's growing exponentially. It's increasing very quickly. The y-intercept is 0, 1. Reason being, anything to the power of 0 is 1. So if we look at a couple of graphs of an exponential, so if I have 2 to the power of x, nice straightforward one. There's my exponential. Okay, I can move that, leave that one there. Y equals, now if I put 2 to the power of negative x, let's see what happens here. It's a straight line. Why did that happen? Because it didn't take that as my exponent, so I'm going to put brackets around here. Okay, so there you go. So you can see it's a reflection on the y-axis. We can move them. If I add 5, for example, you can see that one's just moved up 5, and we'll talk about those in more detail. Last one, logarithmic. Anything with a log in it. Okay, you've done logs before, so you know that that's going to be either a log to the base anything, or even a natural log can fall in here as well. Your x-intercept in this case is always 1, 0. Okay, and the same reason, because anything to the power of 0 is 1, and your log graph looks like that. Okay, so you're going to have to really get to know these, what the graphs look like. So you need to go, there's a great couple of pages in your textbook for you to have a look at, so you can get to know what all these graphs look like. So if I have y equals log x, you can see that logarithmic graph there. So what I need you to do now is review these type of graphs. So either watch this video again or go to your textbook, because I think there's 3 pages in your textbook showing the graphs. You really need to be able to identify them from sight and know what the graph looks like. So what I mean by that is, if you see something being divided by x, you need to look, you know there's a hyperbola, you're going to have 2 asymptotes. What if you have a cube in your graph, so you know you've got a cubic, what kind of graph can you expect from that? Okay, so make sure you really understand what each one is.